Welcome back. Now let us discuss about block diagram representations. Okay. There are two types of representation, two types of block diagram representations. One is direct form 1. Direct form 1 and the other is direct form 2. These are the two types of block diagram representation in this particular unit. One is direct form 1 and the other is direct form 2 representation. Okay. Now here also for two types of equations. One is differential equation. We need to write the block diagram representation for direct form 1 and direct form 2. Difference equation gunu tara direct form 1 direct form 2. Therefore altogether differential and difference equation ಎರಡಕ್ಕೂ ಸೇರಿದ್ರೆ ನಾಲ್ಕಾಯಿತು. ಡೈರೆಕ್ಟ್ ಫಾರ್ಮ್ 1 ಡೈರೆಕ್ಟ್ ಫಾರ್ಮ್ 2 ಫಾರ್ ಡಿಫರೆನ್ಸ್ ಈಕ್ವೇಷನ್, ಡೈರೆಕ್ಟ್ ಫಾರ್ಮ್ 1 and ಡೈರೆಕ್ಟ್ ಫಾರ್ಮ್ 2 ಫಾರ್ ಡಿಫರೆನ್ಷಿಯಲ್ ಈಕ್ವೇಷನ್. ಓಕೆ. Now take the question directly so that it will be easy for you for me to make you understand about how to solve and write the block diagram. Okay. Draw the direct form 1 and direct form 2 implementation for the system. Draw direct form 1 and direct form 2 implementations for the system given by the differential equation d by dt of y of t plus 5 into y of t is equals 3 into x of t. This is the differential equation which is been given. Now we need to write the block diagram for this differential equation correspondingly. Now here we need to make some of manipulations. See here. These differentiators need to be eliminated. In the equation we need to have only integration because we have integrator and summer. Integrator with respect to continuous case and summer or adder with respect to discrete case. Since we have only integrator with respect to continuous case, this is a differential element. This is nothing but a differentiation. Right, now how to convert this into the integration form? Right, if I integrate this equation throughout by one time, because the degree maximum degree in this entire equation is 1 because d by dt is there. If there is d square by dt square, we need to as a maximum differential parameter, then I would have needed to integrate throughout this equation 2 times. Based on the degree, the maximum degree of differentiation present in the given differential equation, that many number of times which is equivalent to the degree, I need to integrate it. Okay, integrate the entire equation. Now since it is only 1, the degree is only 1, I need to integrate this equation by 1 time throughout. Therefore integration of d by dt into y of t is, the differential element will get cancelled with the integral element, therefore it becomes y of t plus, since this is y of t, integration of y of t is, I will be writing it as y1 of t or y dash of t, simply y1 of t, okay, is equal to 3 into, simply it is x of t, therefore it is x1 of t, one time integrated equation. Now this is the reduced equation that I have. Okay, now one more reduction that I need to make here. I need to have in LHS only y of t, which is equal to, I need to have only y of t, rest everything should be in the RHS of this equation. Therefore it will be 3 into x1 of t minus plus 5, if it is been moved to RHS it becomes minus 5 y1 of t. Right, now this is the standard, or this equation is in the standard form to write both direct form 1 as well as direct form 2 representation, I mean the block diagram representation. Right, now I have input this side, the point which is being marked, or if it is not visible, say if this is the point where the input is x of t, right, and somewhere here I have another point, say y of t, right. there has to be a flow from input to output. See, if there is some block, if there is some system, if I give some input to that system, I need to get the output out of that system, isn't it? Therefore, if this is x of t, now what is y of t? Ultimately, it is x of t, which is been written here, and we have in the equation x dash or x1 of t, where one time integrated, isn't it? Now x1 is simple x of t is not there in this equation. Do we have any simple x of t in the entire equation? No. But we have x1 of t, one time integrated. Therefore, directly I cannot connect this dot to y of t. Because y of t equation doesn't have a direct form of x of t, isn't it? Therefore, I need to take downwards and I need to integrate this one time. Correct? I integrate that one time and then I need to give it to the mainstream after integrating it. Okay, na innu I'll reach agilla because still y dash of t is there, right? Now the coefficient of this integration x dash of t ಬಂತಲ್ವೇನ್ರಿ ಇಲ್ಲಿ x of t ಇನ್ಪುಟ್ ಕೊಟ್ಟಿದ್ದೀವಿ, ಇದು ಇಂಟಿಗ್ರೇಟರು. ಇಲ್ಲಿಗೆ ಬರೋ ಅಷ್ಟೊತ್ತಿಗೆ ಏನಾಯ್ತದು ಎಕ್ಸ್ ಒನ್ ಆಫ್ ಟಿ ಆಯಿತು. ಕರೆಕ್ಟಾ? ಆಫ್ಟರ್ ಇಂಟಿಗ್ರೇಷನ್. That is what the representation or notation that we are following. Therefore, this is x1 of t. Now, coefficient ಇದೆ ತಾನೇ ಇದಕ್ಕೆ. Therefore, it will be 3 over here. Plus 3. Right? After moving it to RHS, we have plus 3. Right? Now, this is there itself been retained as it is. 3. Now, this need to be added up to the summer and need to be continued. From y of t, I need to take back that as my input and I need to give it to the integrator so that I'll be getting y to the power of 1 of t. Correct andre? Y to the power of 1 of t ಬೇಕು ತಾನೆ ನನಗೆ. Therefore, I am retracing it from output itself. y of t ಇಂದನೇ ಹಿಂಗೆ ತಗೊಂಡಿದ್ದೀನಿ, ಅದನ್ನು ಇಂಟಿಗ್ರೇಟರ್ ಕೊಟ್ಟಿದ್ದೀನಿ. Then I'll be getting y1 of t there. And this need to be added to the mainstream. Okay, with the coefficient ಏನ್ರಿ ಫ್ಲೋ ಹಿಂಗೆ ಹೋಗ್ಬೇಕದು. Okay, I cannot write in the reverse way. This need to flow this side and backward ಬಂದಿದ್ದು ಮತ್ತೆ ಈ ಕಡೆ ಫ್ಲೋ ಆಗಿ ಹಿಂಗೆ ಹೋಗ್ಬೇಕದು. Okay, and here it is towards right hand side only. Right? Now the coefficient of this is ಏನಿದೆ ಅಲ್ಲಿ y dash of t ಗೆ or y1 of t ಗೆ -5 ಇದೆ ತಾನೆ. Therefore it is -5. This -5 has been obtained after moving that to RHS. Okay, therefore after that procedure only I can able to write this. Therefore -5 is also been added to the mainstream and the coefficient of this will be equal to 1. Okay, now this is the direct form 1 representation. Very simple. This is df1 representation. Hope everybody has understood this, right? And the next direct form 2, whatever the block diagram I have written over here, right? Now to get x dash of t, one integrator is needed. To get y1 of t, one integrator is needed. For both only one integrator is needed, or otherwise even if there are many, we'll come to know that in the next example. One summation is there. This is input x of t, which is towards right side and it is moving further, right? Now these 3 points has been shifted this side, right? Therefore only one integrator is enough and this has been moved this side. Therefore this has been moved this side means it has to be towards this side now and added to the mainstream with the coefficient -5. And the other side, this coefficient is 3. This will be moved this side, right? It is like this. Okay, so therefore it is +3 and which without this part I need to give it to the mainstream y of t. Now this is the direct form 2 representation. Direct form 2 representation. Simply I need to merge this by taking only one integrator element. Okay, now with respect to this example, we have arrived at this only one integrator. Later on, probably we might need one integrator for towards the input side and two integrators with respect to the output side. After merging it, two input, I mean, there I'll be getting two flows to the left side of this block diagram and only one flow towards the right side of this block diagram after interchanging its position. This is direct form 2 representation. The arrow mark in the upper branch should be towards right hand side only, and in the lower branches, depending upon what we are considering, either the input or output. If it is input, it should be moving towards right side. If it is taken back from the output, it should move towards left side. And according to this procedure itself, after shifting its position, the same thing need to be maintained here also. This is moving towards left side, therefore this should also move towards left side, and this is moving towards right side, therefore this should always be moved towards right side, which is following according to the direct form 1. This is direct form 2 representation for the given differential equation. Let us see one more example with respect to direct form 1 and direct form 2 representations. Yes, I will be repeating. The question will be, draw the direct form 1 and direct form 2 representation for the given differential equation, and the given differential equation is as follows: d square by dt square of y of t plus 5 into d by dt of y of t plus 4 into y of t, which is equal to d by dt of x of t. Okay, now if this is the given differential equation, here nothing to worry. No, I mean, there will be no initial conditions, no input form, nothing. Only the differential equation will be given to you in order to write the direct form 1 and direct form 2 representations. Okay, now if this is the given differential equation, now I need to have it in its general form. Correct? I need these differential elements. I need only integrators in my equation to write its corresponding block diagram. Therefore, what is the maximum degree present in this particular equation? It is 2. Therefore, I need to integrate this entire equation by twice. Therefore, after integrating it twice, I'll be getting y of t, because two differential elements will get cancelled with integration twice. Therefore, y of t will be left behind, plus 5 into one time integration ಮಾಡಿದ್ರೆ differential element ಹೊಟ್ಟೋಗುತ್ತೆ. ಇನ್ನೊಂದು ಸತಿ ಹಂಗೆ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿದ್ರೆ ಅದು y1 of t ಆಗುತ್ತೆ. ಕರೆಕ್ಟಾ? Here it is simple y of t, here it is y1 of t plus 4 into, here we have only y of t, there is no differential element. Therefore, if it is integrated twice, what will it be? What is going to happen here? y2 of t. Correct? It is y2 of t is equal to one differential element. We are integrating this entire equation twice, therefore it will be x1 of t. ಕರೆಕ್ಟಾ? ಒಂದು ಸತಿ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿದ್ರೆ ಡಿಫ್ರೆನ್ಷಿಯಲ್ ಎಲಿಮೆಂಟ್ ಹೊಟ್ಟೋಗುತ್ತೆ, ಬರೀ ಎಕ್ಸ್ ಆಫ್ ಟಿ ಉಳ್ಕೊಂಡಿರುತ್ತೆ. ಆ ಎಕ್ಸ್ ಆಫ್ ಟಿನೂ ಮತ್ತೆ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿದ್ರೆ ಇಟ್ ಬಿಕಮ್ಸ್ x1 of t. ಲೆಟ್ ದಿಸ್ ಬಿ ಇಕ್ವೇಷನ್. ಇನ್ನೂ ರಿಅರೇಂಜ್ ಮಾಡಬೇಕು. ಐ ನೀಡ್ ಟು ಹ್ಯಾವ್ ಓನ್ಲಿ y of t in the LHS and every other expression need to be moved to the RHS. Therefore it is x to the power of 1 of t. Coefficient 1 ಇರೋದು, ಇಲ್ಲೇನೂ ಇಲ್ಲ. Therefore been retained as it is, x to the power of 1 of t minus 5 into y to the power of 1 of t minus 4 into y to the power of 2 of t. Now the coefficient of this y of t should be always equal to 1. ಇಲ್ಲೇನಾದರೂ 2 ಇದ್ದರೆ ನೀವು ಮತ್ತೆ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿದ್ದಲ್ದಲೇ ಥ್ರೂ ಔಟ್ ನೀವು ನೀಡ್ ಟು ಡಿವೈಡ್ ಇಟ್ ಬೈ 2. therefore 2 by 2 will be equal to 1. 5 by 2 is equal to 2.5. 4 by 2 is equal to 2. 1 by 2 is 0.5. ಈ ರೀತಿ ಚೇಂಜ್ ಆಗುತ್ತೆ. The coefficient for y of t should be always equal to 1. Right? Now this is the equation which is in its general form. Now I need to start drawing the direct form 1 and direct form 2 block diagram representation. Okay, direct form 1. Now tell me, input x of t ಇರಬೇಕು, output y of t ಇರಬೇಕು. ಇಲ್ಲಿ somewhere else here output y of t ಇರಬೇಕು. Okay, now can I able to direct this x of t to y of t? ಡೈರೆಕ್ಟಾಗಿ ಜಾಯಿನ್ ಮಾಡ್ಬೋದಾ ಇಲ್ಲಿ? yes or no? Directly I cannot able to join this x of t to y of t because I don't have any simple x of t. we have x1 of t, isn't it? Therefore, I cannot able to join this directly, right? Therefore, I need to integrate this once first. After integrating it, I'll be getting x1 of t. And the coefficient is 1. Here also the coefficient is 1. Therefore, I need to write nothing there. Correct? I need to give this to mainstream summation. Now I need to take some form of that particular output and give it to the integrator, so that I'll be getting y1 of t here. Isn't it? Here it is y1 of t. Now is that enough? If I simply give y1 of t to the mainstream, I need to add one more summation here, because one more input I need to take it here. Therefore, this coefficient, that coefficient will be equal to, with respect to y1 of t, it is -5. Therefore, I'll write -5. And with respect to x1 of t, it is simple 1. The arrow mark need to be mentioned over there with 1. And further continued with that, one more integrator I need to add. It is not yes, it is integration. It is not yes, you should not write it as yes, right? Now one more integration, I'll be getting y2 of t. And what is the coefficient of y2 of t? And this has to move towards this side, and this has to move towards right side only, as I told you before. And the coefficient is -4, and this need to add it to this mainstream. Okay. Now this is moving towards right side with the coefficient of 1, as always, as I told you before, right? This is direct form 1 representation. Now how to write its corresponding direct form 2 representation? This need to be shifted this side, and this need to be shifted that side. Therefore, the integrator will come towards the center. Now what is the maximum number of integrators that we have in this entire block diagram? It is 2. Therefore, I need to have 2 integrators at the middle, right? I need to have 2 integrators. Now one input here. Now since this has been moved towards this side, this summation obviously will be here, isn't it? The summation, if this entire thing is been moved towards this side, right? Now from here, one integrator, one more summation here to add the next output from this integrator as well, I need to add it there. Therefore, the coefficient here is -5, and with respect to this is -4. Simply I'm moving here, and I need to give it to the mainstream, and this is moving towards that side, right, as it is being drawn there. And here only one integrator output is essential. Therefore, with the coefficient of 1, only one integrator output is enough, and this need to be given to the mainstream y of t with the coefficient 1, right? This has been moved this side, and it has been written as it is. This is direct form 2 representation of a differential equation. Hope everybody has understood this, and keep solving more and more number of numericals with respect to this also. In the next, we shall see the block diagram representation of difference equation. See here, we need the integrators. To get the integrators for the given differential equation, we have integrated the given equation based on the degree, maximum degree that is been given in the question. Those many times we have integrated the equation, and it has been written in the standard form by making its coefficient equal to 1 and is equal to the rest of the other parameters move towards the right side of this equation, isn't it? And based on this equation, we have obtained the block diagram representation of direct form 1 and direct form 2 respectively. Very simple to understand, right? And next we shall see the block diagram representation with respect to difference equation. With respect to difference equation, I'll be discussing it with straight away the example. Draw the block diagram representation direct form 1 and direct form 2. Or the question will be like this: draw the direct form 1 and direct form 2 implementation for the system described by the difference equation system described by the difference equation like this: y of n plus some constant y of n minus 1 minus 1 by 8 into y of n minus 2 is equal to x of n plus x of n minus 1. This is the difference equation, isn't it? This is the difference equation which is given in the question, right? Now we need to draw the direct form 1 and direct form 2 representation, direct form 1 and direct form 2 representation for this difference equation. Okay, now as we have done with respect to differential equation only, in LHS we should have y factor, and rest all should be moved towards RHS of the equation, and the coefficient of y of n should be always equal to 1, as I told you before. Therefore, upon rearranging this, no need to integrate or differentiate anything with respect to this simple manipulation. Therefore, y of n is equal to, upon moving the all other parameters towards right side of the equation, it becomes x of n plus x of n minus 1 minus 1 by 4 y of n minus 1 plus 1 by 8 y of n minus 2. Hope it is clear. We have simply moved the other parameters other than y of n to RHS. Therefore, this is the equation and the coefficient is 1. You should make sure that the coefficient is 1 to this equation. Now, this is in its general form. Right? Now, I have input and I have output marked there. Right? Now, if this is x of n, the first point, now do we have x of n in its direct form? Yes, I have. Therefore, I can have a straight line over there. First draw the straight line, later on I can mark the summations in between wherever required. Okay, now there is x of n straight away. Now one more x factor which has been present in this particular equation, x of n minus 1, isn't it? Therefore I need to take this x of n and I need to make this, give this to a system which delays by 1 unit. Once one delay element makes the input or output, whatever it is, makes the function delayed by 1 unit. Therefore, the output out of this will be x of n minus 1. Right? And the coefficient of that, what is the coefficient of x of n minus 1? It is 1 itself. Therefore, I have written it as 1. And this is added to the mainstream. There are no further inputs, that is, there are no further x of n's, only two x of n. One is direct x of n and another one is x of n minus 1 in this form. Therefore, I need to add it to the mainstream. Now, coming to y of n, there are y of delayed versions of y of n minus y of n. Therefore, I need to take the output, take the output from this point, give it to one delay element, and this becomes y of n minus 1, and we have n minus 2 as well. And before that, I need to give this to the mainstream by adding it the summation, and there also one summation to add this input with that input. Okay, and the coefficient of this is equal to 1 always. And what is the coefficient of this? Y of n minus 1, it is minus 1 by 4. Therefore, this is minus 1 by 4. And further delayed by 1 unit. Therefore, I will be getting y of n minus 2. Why it is n minus 2 here? Because this is being taken, is being applied to two delay elements consecutively. First delay y of n minus 1, second delay, therefore y of n minus 2. Therefore, I need to add this to the mainstream with the coefficient. What is the coefficient? It is 1 by 8. Isn't it? Now this is direct form 1 representation of a difference equation. Drawing a block diagram, both direct form 1 and direct form 2, is simple with respect to difference equation. In differential equation, we need to integrate it and write it in a standard form and write its equivalent block diagram. But here it is very simple. Now direct form 2, this is direct form 1 representation. Now direct form 2, this portion need to be shifted here and this portion need to be shifted there. Therefore, a straight line is already been existing to this, In the middle we need to have the delay elements. How many maximum delay elements are necessary? Two delay elements, therefore I am drawing two delay elements in between. And towards this side it is this block, therefore one summation should be there here and one summation need to be present over there. Now two outputs from each delay element. This is towards the mainstream and this is also towards the mainstream, right? And this is been moving towards left side here because these two are moving towards left side, therefore the coefficient here is minus 1 by 4 and the coefficient here will be 1 by 8. Now the input is taken from this side, therefore with the coefficient of 1 unit, and has been given to the mainstream, and the coefficient here is 1, which is y of n, and this is x of n. This is direct form 2 representation. Very simple representation. This carries marks, minimum 6 marks. Right, now this is direct form 2 representations. Right, now for any equation that has been given to you, you need to rearrange the given difference equation in its standard form and then start drawing the block diagram representation of this particular difference equation, both direct form 1 and direct form 2 block diagram representation. Now say similar type of questions you need to solve and prepare thoroughly to face the test. Thank you. In the probably you can study solution to difference equation on your own based on the concepts that I have told you with respect to differential equation. Okay, and the test portion will be differential equation one question, difference equation one question, and block diagram representation either difference or differential one question, and two questions from applications of Fourier transformation. Okay, now try to look into the applications of Fourier transformation. Whatever I have discussed so far, try to look into it, and similar types of questions ಯಾವುದೋ ಒಂದು 3-4 ಕ್ವೆಶನ್ಸ್ನ ಸಾಲ್ವ್ ಮಾಡಿರ್ತೀವಿ. ಯು ನೀಡ್ ಟು ಸಾಲ್ವ್ ಮೋರ್ ಆ್ಯಂಡ್ ಮೋರ್ ನಂಬರ್ ಆಫ್ ನ್ಯೂಮರಿಕಲ್ಸ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಇಟ್. ರೈಟ್, ಆಲ್ ದ ವೆರಿ ಬೆಸ್ಟ್, ಡೂ ವೆಲ್ ಫಾರ್ ದ ಟೆಸ್ಟ್.